Hello. In this lecture presented by www.free-academy.com, we're going to be doing my Achilles heel, and that is explaining how to do the derivative chain rule. The chain rule is one of these things that's really easy to understand once you get it, and it really shouldn't be that difficult to explain, but for whatever reason, I've always had difficulty explaining this to students. So bear with me, I'll do the best I can. There's two different ways of writing the chain rule. The one that I think is easiest for the student is what I wrote first. What's probably more mathematically proper, and some students might find this easier as well, is the second term that I wrote. But either way, it's used for finding the derivative with respect to x of the combination of f of g of x. Now, I did lots of problems at the beginning of this course that you should check out on the website if you are having trouble with f of g of x. If you're combining functions, you need to understand very well in order to do the chain rule well. And what I've found is that is the most common problem calculus students have with doing calculus, is that they have difficulty understanding how to combine functions of this nature. But when you're looking for the derivative of f of g of x, it is equal to the derivative of the outside multiplied by the derivative of the inside. And I'm going to take up an example of this right away. We'll do the derivative with respect to x of sine of x squared. So in this particular situation, we're going to call f equal to sine of x, and g of x will be equal to x squared. So then we're going to need f prime, which is equal, derivative of sine is equal to cosine. And we'll need g prime, the derivative of x squared is equal to 2x. So notice I've left the parentheses here and I didn't put the x in. This is really to accent that x just acts like a placeholder in our situation. We'll write out f, which is, we need f prime here. So this will be the cosine. And inside these parentheses, we put g of x, which is x squared. And then we're going to multiply the whole thing by the derivative of x squared, which is equal to 2x. So the derivative of sine of x squared is equal to the cosine of x squared times 2x. We've literally taken the derivative of the outside and then multiplied it by the derivative of the inside. And the important and functional thing is when you do this, that your arguments stays the same from one equation to the other. Now, to be rigorous and to explain the alternative explanation, we have df dx equals df dg plus dg dx. So to find the derivative with respect to x, this time we're going to use the cosine of sine of x. You notice that f is equal to cosine of x, g is equal to sine of x. G equals sine. And no matter how you do these problems, you're always going to need f prime, and you're always going to need g prime. So to find this derivative, you do df dg, which is negative sine g of x is equal to sine of x. And this will be multiplied by dg with respect to x, which is cosine of x. The idea behind this formulation here is that if you were to cancel these two dg's, then you would get df dx equals df over dx. So that's the evolution of that equation. Whichever makes more logical sense to you, you should use. Be aware that I'm going to stick with this a little bit more, derivative of the outside multiplied by the derivative of the inside. And that is the derivative chain rule. We're going to do tons of practice problems on this, so you can learn this through example just in case you weren't able to follow me in this lecture.